Welcome friends, let us today discuss about the digital pH meters. So the digital pH meter has two main ingredients. One is the pH meter and another one is the pulse width modulator. So we are going to organize our discussion point wise like this. First we shall learn about the pulse width modulator. Second we will understand the pH, and then we will go for learning about the working principle of the pH meter, and together we shall understand how a pH meter works and what is the working principle. So let us start with the pulse width modulation technique which the pH meter makes use of. We use the basic circuit like this. You have the op amp, and this op amp is used as an integrator. So the inverting input is given a feedback capacitor like this, and the input to the inverting input is provided with a clock pulse which is negative going. I mean, from 0 it will go in the negative direction for some time, then it will come back again, it will go to the negative direction for some time, then it will come back. Like this it will work. So this is the complete period, and this negative going cycle will produce a negative magnitude of the input clock pulse, and which will continue as the duty cycle for the clock pulse. So with this, the non-inverting input is provided with the ground, and the output of the integrator will go to a comparator through a resistor. So this comparator will compare the input voltage Vin, which is a DC input voltage, and that has to be measured and converted into a corresponding pulse width modulated waveform. So we have a pulse width modulated waveform. So let us understand how the clock pulse will modify the input voltage that is to be measured here and converted into PWM. So we start with a clock input. So let us have a waveform here like this. So we will see that the clock pulse is input here, and because of this negative going end of the clock pulse, there will be the negative charging of the capacitor on the front end and the positive charging on the other end. So we can understand that if the clock has a negative going cycle, then a period for which the capacitor will be charged negatively, then it has a positive going cycle, then again like this we can go. So during the period the clock pulse is negative, the front plate of the capacitor, that is the plate on which the capacitor will be charged negatively, so we can show this voltage as your C minus from ground. This is initially grounded, so from here we can say that the voltage will go down like this. Voltage will go down like this till the time I am reaching the positive going edge of the clock cycle. So again at the positive going edge, I can see that the positive charging is there. Actually, in a real situation, when the clock is charging the capacitor, so it will charge like this. It will charge the capacitor like this, 1 minus exponential minus t by RC. So this is the voltage development, then this is the discharging. So you can see that this is equivalent to a triangular waveform. So that is why I have drawn a triangular waveform over here. So now this situation continues for a given voltage, and charging and discharging will happen. So on the opposite side of the capacitor, the other plate will charge oppositely. So if I say that this is a 0 voltage situation, so this will charge like this, then like this, again 0, and it will continue like this, again come to 0 like this. So this is on the positive plate of the capacitor. So because of this, what you will see that the inverting input it get a voltage raised like this, and an input voltage, a fixed input voltage of DC is entering the non-inverting input. So because of this, we see that when the capacitor secondary voltage C plus is greater than Vin, the pulse width modulated voltage waveform at the output will be like that. Initially there is a voltage which is positive, but after some time when BC plus is greater than Vin, at that time the output of the comparator will be 0, and this can be considered as your off period of the pulse. So we can say that suppose you have the capacitor secondary charging which is coming into the inverting input. Say I take 2 voltages over here. So suppose the input voltage V in, one voltage is V1 and the other voltage here it is V2. So here I have taken V1 greater than V2. So what will happen here? Let us check. When this capacitor voltage is greater than this, that time the output of the comparator is negative, and after that for this period V1 is output is on, or this output is positive. So this is the period for which the pulse is on. I can say this is the period T1. Similarly for V2, I can say that for V2 this is the period for which the comparator is on. So here this is the period for V2 and I take it as T2. So I can see that T1 is greater than T2. So input voltage is correspondingly converted into a pulse of modulated pulse width, because higher is the input voltage, higher is its on time. So that is why I can say that the input voltage Vin is pulse width modulated at the output. So that is how the pulse width modulator will work for this circuit. So we can understand that for digital measurement of the DC voltage level, the pulse on period gets a fixed frequency from a crystal oscillator clock, like in our case here I got a fixed frequency, while I had the opportunity to modify this width also. So the increase in the on period of the pulse causes the final counter reading to increase. So that is how I am using this circuit as a pulse width modulator for the given DC input voltage. Now let us see how the pH meter works. So before understanding the pH meter, we make an idea about the pH. So we have a water molecule H2O. This is basically a covalent bond of hydrogen and oxygen, but whenever something ionic, maybe in the form of cation or anion, is added to a pure water, it starts showing the tendency of ionic bond. So whenever we are using H2O solution with some ionic component, it is becoming ionic, and in that situation the kind of solution added or kind of component added to H2O can be determined by the concentration of H plus or OH minus in the solution. So we understand it in this way, that the concentration or activity of H plus and OH minus, that is the molar concentration, activity is a molar concentration, is together 10 power minus 14, which is a fixed value. Now we say that for a water of the kind of neutral water, both the concentrations are same. So I can say that the concentration or activity due to H plus is 10 power minus 7 and due to OH minus is 10 power minus 7. OH minus is 10 power minus 7. Here I have the idea of taking logarithmic of negative logarithmic of the concentration of the ion H plus, that is the protonic part. So I can say that pH, that is a power or potence of H, equals to minus log concentration of H plus. So that is equal to minus log, this is base 10, log base 10 concentration of H plus 10 power minus 7. So this is equals to 7 log 1 is 1, log 10 is 1. So I can say that for a neutral water, this is pH and pOH minus, both are 7. Now I can see that if the concentration of one of the components like H plus changes 10 power minus 6, so the concentration of OH minus should become 10 power minus 8 to make the complete balance of 10 power minus 14. So that is why if the concentration of H plus is less than 10 power minus 7, therefore concentration of OH minus is greater than 10 power minus 7. So that is called basic or alkaline solution, basic or alkaline solution. And in case we have concentration of H plus is greater than 10 power minus 7, and concentration of OH minus is less than 10 power minus 7, we say that it is an acidic solution. So in this case, if it is 10 power minus 6 H plus concentration, means this is an acidic solution, so it will be satisfying this condition. Concentration is greater than 10 power minus 7. Well, in that case, potence of H, that is pH, equals to 6 and potence of OH equal to 8. So this is basically an acidic solution. You have to be careful about this, because if it is less than 7, the value of pH is less than 7, then it is acidic. If it is greater than 7, then it is a basic solution. Let us see some real examples of the pH values of different components. So here we see that neutral value of pH is almost, for the case of blood, which is 7.4. So this is greater than 7, so it means this is blood is little alkaline. Then we can see that what are the compounds or components in which we get acidic solution, that is black coffee or grapefruit, lemon juice. Lemon juice has pH 2, so it is very much acidic, and battery has pH 0. So we can understand by this that the less is the value of pH, more acidic is the solution. So with this idea of pH, let us understand how. So with this idea of pH, let us understand how the digital pH meter works. So for that, let us first understand about the pH meter. So a pH meter is basically a couple of electrodes which has the reference electrode and the other electrode, which is basically the pH meter. So we have a container with a perforated membrane over here, This is a ceramic membrane with perforation, so small perforation that only small compounds can pass through it. Then this, along with an electrode, which is the reference electrode of metal, is placed together to form the electrode pair. So here the perforated membrane is associated with a glass bulb sensor. Here at the bottom, this is glass bulb sensor, and this is the reference electrode. Now this glass bulb sensor will have the conductor with it, and the reference electrode will also have the conductor, which reference electrode is grounded, so through some resistance value this glass bulb electrode's output is sent for further measurement. So here what happens, that you are willing to measure the pH value of a solution like here. So pH value of a solution, I am saying it means that this solution has H plus and OH minus. Especially it should have the H plus. So this glass bulb sensor will sense the presence and movement of H plus ions as protons near it. So this perforated container will have the potassium chloride solution. So once this is placed in the solution, whose pH value has to be measured, there is a movement of H plus towards this KCl compound, while the K plus will try to move towards the solution through the perforation. So because of this, there is a movement of K plus in the solution within the porous container. So this movement of K plus will create an electric field or electric potential across the places, like I'm showing it with another color. So this is the place you have the K plus concentration, and this is the place you have the K plus concentration. So there will be electromotive force because of the transition of H plus towards the perforation. So because of this movement of K plus and H plus, this glass bulb will sense movement of the cations near its vicinity. This movement is sensed by the glass bulb and it converts it into a voltage and sends to the circuit. So because of this change of concentration of the porous container of pH meter, the pH of the solution which has to be measured is translated into a corresponding voltage by this glass bulb sensor. So once this happens, then the corresponding voltage at the output of the glass bulb sensor will be sent to a pulse width modulator circuit. So this is the input voltage of the pulse width modulator circuit, as we have learned earlier. So this is the pulse width modulator circuit or converter. So output of this converter will be a pulse width modulator signal waveform, modulated waveform, for which higher the value of V in, higher will be the duty period of the pulse width modulated waveform. So this waveform will enter into a circuit which will have the period triggering and the counter. This counter has very high capacity of 4 hex bytes. 4 hex bytes means 4 counters of 6 into 8 bits. 6 into 8 bits. So this counter will keep on collecting the information of the changing pH values through a complete cycle of set and reset of the counter. This output will be displayed. This output will be displayed and recorded as well. So we can understand that pH meter, which digital measuring facility, will run with very high level of accuracy, because the kind of sensor used in pH meter with glass bulb sensing facility is very sensitive and reads to the accuracy level of as high as 0.005% of error. So with this, our study of digital pH meter is completed, and a digital pH meter, as I am summarizing, will contain a pulse width modulating circuit. So that will be a pulse width modulator converter, and along with a pH meter, these two together will form the digital pH meter. If you find this lecture useful, like the video, kindly subscribe it with public domain subscription and set the bell icon for future communications. You can send me email to my email ID emmifaq@gmail.com. So this much is for today. Thank you for your patient listening.